So, welcome everyone. We are going to discuss concepts related to sampling, um, especially in the context of biostatistics. So, sampling is when we select a few members from a larger population and then study them and then make conclusions about the general population. Basically, when we want to understand, for example, we want to understand the prevalence of diabetes in a given country or county, we need to first understand who are the people that are of interest as far as our research topic is concerned. Okay, so our research topic would be concerned about prevalence of diabetes amongst individuals aged, let us say, 20 to 40 years. Okay, so all the individuals who live in that particular country or county can participate in our study as long as they are between the ages of 20 and 40. So they have definitely everyone who is within the age of 20 to 40 within that particular location forms actually what we call the population. So the fact that we cannot actually conduct a study for all the members of that population, we need to pick a few from them. So the few that we pick are the ones we call the samples. So they should be representative of the entire population, such that the researcher can actually be able to make very good conclusions from them. Yes. So that is very, very key. So researchers have to be very careful in who they select to participate in the study. So it's about who and how many are supposed to be representative. Because if we don't make them representative, then it is going to not, we are not going to make very good conclusions about our research study. So usually, a population, they have their own unknown characteristics. Okay, there is an average age for the entire population, but we don't know that age because we have not really determined it. There is a, let us say, a range. There is their proportions, their what, but we don't know the things because we cannot really take measurements about them for the entire population in a given geographical location, maybe a county, a country, a state. We cannot do that. So what we usually rely on and what we can measure from samples. Okay, so the characteristic of an entire population that we don't know is what we call a parameter, but a statistic is that characteristic of a sample that we can actually determine because we can measure it. So that's the difference between parameter and statistic. So the unknown is what we want to know, but we can know the unknown using the samples. Okay, but of course when we get what we can know from samples, it may not be exactly like what we would have gotten if we had taken the measurements of everyone in a population. So therefore, there is always that variation. You're not very sure whether what you have from the sample is actually what is the reality if you had taken it from the whole population. So that concept is what you call precision. So we make conclusions about a population based on what we have from a sample. So that process of making those conclusions based on what we get from the sample is what we call inference. For you to determine how many and maybe how you're going to do the sampling, how many people are you going to include in your sample? You need to first understand the whole picture, which is how many people are actually fall within that population of yours that you have actually looked at. So if it is about patients who have visited a particular health facility, then you need to look at the whole list. And after looking at the whole list, then you can determine. So the whole list of the sampling units, or the members that have the individuals or the elements within a given population is what we call a sampling frame. You need to have that for you to be able to draw samples from the population. So the sampling units are the individuals or the elements that you're really interested in. Where are you going to collect the data exactly? Where is it? Okay, are you going to collect the data based on patients who are coming to the facility, or are they going to be the health workers? Okay, or you're going to based on the medical records within the hospital. So where are you going to collect the data from? Okay, those are the elements or units that you're interested in. And then we move to the importance of sampling. Why do we really need to do this sampling? We don't actually have all the resources on Earth to be able to take measurements of everyone, such that we can make conclusions, and based on the conclusions we can make decisions. That is not actually feasible. So we have issues to do with feasibility. We don't have the time, we don't have the resources, and if the research is actually having issues to do with placing burdens on participants, why do you want to subject everyone to that burden, yet you can actually get what you want from this small group of people, and you can make very good generalization based on that same group of people? So you have ethical reasons, you have feasibility reasons for you to really use an appropriate sample to make conclusions about the population. So we have different methods of sampling. We have probability sampling methods and then the non-probability sampling methods. The probability sampling methods are those that where everyone has an equal chance of participation in the study. Whereas the non-probability methods the members actually do not have an equal chance of participating in this study. In science or in research, we actually prefer the probability methods because they eliminate biases to some good extent, and therefore we can make good conclusions about the general population. So the first method is a simple random sampling. This is where each member, of course, has an equal chance of being selected for the sample. You first need to identify the group or the population of interest, and then assign them a unique identifier, and then those that have a particular identifier of interest can participate. But of course, the identifiers or these generated numbers have to be random. So a simple example is if you have 40 women who have come for their first antenatal visit, but out of those 40, your interest is to get 30 or let us say 20 participants. So you say that you're going to write on pieces of paper figure 1 up to 40, and then you wrap those papers properly, you mix them perhaps in a container, and then they can come and pick. Each one comes and picks a paper. Those who pick an old number are the ones who are going to participate in the study. Okay, so given that the odd numbers are going to be 20, you're going to get the 20 people to participate in your study. When you do that, that is a simple sampling technique. It's very easy to do. You eliminate some biases and you can really make good conclusions without a lot of complicated statistical analysis. And the issue is that you may not really use it if you have a larger population, but also most likely you may have issues to do with sampling errors, and you may not be very sure if each subgroup is actually well represented in the sample. So those are issues that can happen. Then stratified sampling is when you understand that populations are not the same. Populations differ in terms of socioeconomic class, in terms of the gender, in terms of occupation, in terms of education level, wherever it is. Yet what you're actually investigating has a relationship with the different classes that we have talked about, different groups that we have mentioned. So your interest could be that you want to make sure that everyone is equally represented. People of the lower economic class and people of the upper economic class are well represented. The females and the males are also well represented. These are parameters that you're actually interested in, and they should be well represented. So you create what you call strata, which are the different groups. And then from each group, now you can now pick members to form the samples, and this can be actually predetermined. So you can say those in the higher socioeconomic class are going to be 20, those in the middle 20, and then those in the lower 20. So that is stratified. It makes sure that you can actually pick members from each subgroup, and it improves on the precision, and you can do different analysis because you can analyze the different categories and even compare them. So that's the benefit. The limitation is that one, you need to have complete information for you to be able to make to create a very good strata. Some of this information may not actually be available. It's a little bit more complex, and therefore you actually need more careful planning with it. You may need time and also resources compared to simple random sampling. Cluster is when now you say that people are going to be divided into groups, okay, and then you get those subsets of where you're going to collect this data from. So basically, these subgroups, what we are calling clusters, can be administrative divisions. Okay, they can be payams, they can be bomas, they can be counties. So, for example, if you look at it in terms of states, Central Equatoria State has many counties. And you're going to carry out a study. So, which county are you going to carry out the study from? Okay, so you may need to base the data collection based on the different clusters or the different counties within that state. Okay, so and then you say that you're going to get 1,000 people from the other county, 1,000 from the other, 1,000 from the other, and things like that. So that is cluster sampling. So it is usually very practical and cost effective, and also it gives you good information because you have a representative sample, and you can all do this data analysis at the different levels, at the state level, at the county level, and then going downwards. Those are the benefits. And then, of course, you may have issues in analysis, issues to do with cluster effects. You may include some errors because of the clustering. So you actually need to be very careful about the choice and size of clusters, because they will influence the values that you get. So basically with the stratified random sampling, you have the different groups which we call the strata, and then you pick members from each group. And then with the cluster, you have different groups that may be counties, different counties in the state, and then out of the counties, you choose which one you're going to select. That is cluster. Systematic random sampling, this is to assume that you have a group of, let us say, 20 people that you want to study, and out of those 20 people you need maybe, let us say, 6 people to participate. So you say, okay, you may divide the 20 divided by 6, the number that you get. For example, let us say if the answer is 3, answer 3, so you then you select the starting person, okay, and then you say that the first person is 1, the second person is 2, the third person is the one you're going to recruit into the study. So that third person is the kth figure, and we can call that the sampling interval. Okay, so that person is recruited into the study. Then you start also 1, 2, 3. The third person is recruited. 1, 2, 3. The third person is recruited until you get the number of people that you want to recruit. You can say that it's quite simple, less time consuming, and also you get people. You're actually covering you have the possibility that you're covering the whole population, which is actually very good. So you basically have a representative sample. The issue could be that you may introduce bias that you might not have known. So you need to be very careful about that. The other issue is that if you have a list that is not actually randomized, then you have an issue. You may have issues with underrepresentation or over-representation. So the other big category of sampling methods are those that are non-probability, that the members do not have an equal chance to participate or to be selected. So convenient sampling is one of them. You basically contact the individuals who are easily accessible to you in terms of proximity or convenience. They are basically there for you to ask or to collect data from them. So it is very easy. You can also use it when you don't have a lot of resources, and also when you're conducting preliminary studies. The challenge is, very huge one, is that they are very prone to selection bias, okay, because you are most likely going to ask individuals to participate in your study because maybe they are your friends, and because of the fact that they are your friends, they may have a characteristic that may not be representative. They have characteristics that are not representative of the entire population. So it becomes very hard for generalizations to be made. Purposive is when now you deliberately choose who you want to involve in your study because they have particular knowledge about the experience you're investigating, particular qualities or characteristics. So it's very easy because you know who you're looking for, and you can basically use this especially for qualitative research studies. The issues are, which are generally also applicable to qualitative studies. One is that they're quite subjective, and making generalizations is not very easy. You cannot easily make generalizations. Excuse me. Then we have Snowball. This is where the initial person you have contacted leads you to the next people because they know them, or because they know that they have particular expertise, or they have undergone a particular experience, or things like that. So it's also quite very easy to use if you have if you're actually studying a topic that is quite rare, but also if individuals are hard to reach. Of course, so the initial participants use their social networks to connect you to who you may interview next. Of course, the issues of bias are very common, and you don't have actually control on the sample composition because they just basically refer you to go to the individuals. So how do you determine the sample size? The sample size is very important because it allows you to make very good conclusion or inferences. So it is very, very, very vital. If you have a sample size that is actually less, you're not going to make wrong conclusions, wrong estimates, and you not have what we call statistical power. There are many factors that you can depend on to determine the sample size that you actually need. So let us look at those factors. One is the effect size or detectable difference. You see, you may be interested in, for example, knowing whether when you take a drug B, it decreases the blood pressure. Okay, so how are you going to know that the drop in the blood pressure is because of the drug B that you have taken? That's what you call the effect size. Sometimes it may be very difficult for it to detect the change because of the drug. Okay, so if it is very hard for you to detect that effect, you need a bigger or a larger sample size. That is very, very key. And then the second factor is the statistical power. Statistical power basically refers to the probability of correctly detecting an effect, if indeed it exists. Okay, so is it really true that the drug B causes a change in blood pressure? Okay, so if you can detect that indeed the drug B causes a change in blood pressure, then that's actually good. Okay, so the higher the probability, the better. Okay, so you can have a higher statistical power if you have a larger sample size. Okay, if you have a larger sample size, if you have few members in a sample, you may not really identify even small changes in blood pressure. What resources do you have? Okay, do you have the time, the budget, and even the participants? How are you going to access them? If you have these resources, then you may need a larger sample size. What research, design, or analysis methods are you going to think about? Usually, qualitative methods do not require a big sample size. Okay, qualitative methods not usually require a big sample size. The desired level of confidence. Okay, to what extent do you want to be certain in the estimated results that you have? Okay, if you're going to have a higher confidence level, such as 99 or 95, then you need a larger sample size. This is to say that you want to have your estimate closer to the population parameter, if you remember. For it to be closer to that, you'll have to take, you may need to make a choice about the confidence interval. What chances are you willing to take for you to say that what I've got is what the reality would be? Okay, so this is also related to the margin of error. Okay, the statistic that you're going to get is going to be different from that of the population parameter. But it's not going to be exactly the same, but what is the margin of error that actually that makes your statistic different from the parameter? It means that if you want to be closer to the parameter, that means it's the smaller margin of error. You need a larger sample size. The more you have people participating, or the more you have a larger sample size, the more closely you are to the right parameter, which is basically also unknown. And then variability in the population. If there is a lot of variation, if you have a population where you have many short people, many individuals who are tall, you get, so it is, if you're going to look at the average age, you may need to have, average height, you may need to have a larger sample size if the variation is going to be huge. Okay, if the variation is actually huge, then you need a larger sample size. So you can use statistical formulas to determine the population, the sample size. Okay, so the formulas usually you can use calculators or software to determine or to make these calculations. But the considerations are you need to make choices on the confidence interval, okay, and then also on power analysis, which is basically related to what sample size is needed for us to detect a specified size effect with a given population, with a given power level. Okay, so you can use very many methods to determine the sample size. You can look at the previous studies that have been done, and then you look at the sample sizes that they had, and then maybe you can base on that. And what recommendation do they make based on the sample sizes they made? Okay, if a study used 1,000 people, but in their recommendation they say that if a study is to look at this using look at this subject, then it would be better that they use a sample size of, let us say, 2,000. Okay, so they can make recommendations. So you look at what other researchers actually recommend, and then you can use that to determine or to arrive at how many people you need to involve in a particular study. But you also have tables that you can use to determine the sample size. Okay, sample size tables. Okay, they are based on different statistical tests and assumptions. So you can use that approach, but you can also carry out statistical calculations to estimate the sample size needed to achieve statistical power. You can also conduct maybe a small study for you to use in order to estimate the population size requirements. There are issues associated with sampling. If you don't do it in the right way, then you really have discrepancies between the statistic and the parameter. Okay, so you need to make sure that you don't have errors or discrepancies, and you can actually minimize these errors. And you need to minimize these errors because they actually affect validity and the ability to generalize your research findings. So those are issues that you need to address. These errors can happen. Okay, they can happen randomly, or they can be an issue that you actually have with your study. Okay, so it can be random sampling errors, but they are happening by chance. So for you to minimize that, you need to have a larger sample size. A larger sample size is very important. Okay, you need to you need to also be in position to quantify these random sampling errors using statistical analysis. Still, you can also reduce them through statistical techniques. Okay, so advanced statistical techniques can enable you to understand whether the figure you're getting is because of random sampling errors and how you can quantify them. That's very, very key. Other errors can happen because of the sampling process. Maybe you did not select the appropriate samples, or maybe those who you selected did not respond, or maybe your measurements are not accurate. When you have that, of course, your estimates are going to be biased and inaccurate, so you will not be able to make valid inferences. So you need to make sure that you don't have sampling errors, because they affect the accuracy, the precision, and the generalizability of the research findings. So you need to reduce them such that your results can actually be reliable, and then inferences can be made such that correct conclusions can be made. So use the appropriate sampling technique to minimize biases, and make sure that you have you increase the sample size, and also follow the protocols, the sampling protocols. This is to say that in your study you develop what you call protocols, and those protocols basically are the rules for which you're going to conduct this study. So you need to make sure that you follow them very well, and you have checks and balances to see if these quality control measures are well followed. Sometimes you may need to conduct what we call sensitivity analysis to understand the impact of the sampling error on the result findings. Sampling bias is when you, in your sample, you have either overrepresented or underrepresented certain individuals or groups in your sample, and therefore the errors usually result from the design process, the sampling design, the recruitment, and then the participant selection methods. So this actually introduces biases. So the sampling biases can be because of who you are actually recruiting into a study. These people may not be those that actually represent the entire population. So sometimes you have people who don't respond, or people who actually exclude themselves from the study. So you have this selection bias. So it distorts the findings of the study. And then you have those, what you call response bias. You have people who may have particular characteristics, and they're the ones who actually respond, and that may and they may not be actually representative of the general population. Okay, so we have issues of recall bias, issues of interviewer bias, social desirability. So people actually give you responses that that are not exactly what being studied. Okay, maybe they are forgetting information. Maybe the interviewer is asking questions in a particular way. Maybe the respondents want to be to be seen, to be in social conformity. So they give you responses that are not really genuine. So you get what you call response bias. And then maybe the people who are collecting data are not well trained enough, and they are not collecting data in the most appropriate way possible, or perhaps the instruments they are using are not well calibrated, they are not valid, and therefore they cannot produce valid results. So it is very important that the research data collectors are well trained on the tools to use. So still, you do not have valid conclusions about your research if you have sampling bias. So that means that the conclusions you have will not reflect that of the entire population. So make sure that you have the appropriate sampling methods to achieve the fact that the sample has to be representative, and then make sure that you use random sampling methods, what we call the probability sampling methods. Follow the protocols, assess any potential sources of bias through sensitivity analysis. In qualitative study, there are some considerations that we have to take when talking about sampling. The common methods of sampling include purposive or purposeful sampling, snowball sampling, and others. What is very key here is that for purposive or purposeful sampling, you have the people in mind who need to participate in this study. So you can use theoretical sampling, where while you're conducting the data collection process, there are participants who actually emerge that you need to get data from. Or you can use the maximum variation sampling, which is that in your process of collecting data, you need to get people who have different views about a given experience or perspective, such that you don't collect data that actually provides only one angle to one issue. And then homogeneous sampling, you still want to get, if you are interested in a particular phenomenon or experience, you may be interested in people with the similar experiences, such that you can gain in-depth understanding of the specific phenomenon. Snowball is where, like we said earlier on, the initial participant refers you to the next. It's very good in qualitative. Your interest in qualitative. Your interest is to get information that is rich, okay, that give you proper understanding of the topic that you're investigating. You also you do not have a predetermined sample size, but you only reach sample size, the required sample size, if you reach what you call data saturation, when you no longer collect any new data about the particular problem that you're investigating. Then the other thing is that you want to be able to get diverse views, and you can also transfer the findings to other similar areas. Issues of generalizability and or transferability. This is very, very key. Data validation and quality assurance. You need to make sure that your data is accurate, reliable, valid, and also representative. So you need to make sure that you conduct the appropriate, you carry out the appropriate measures to make sure that your studies or your research data that you have collected is actually valid. So you can do a number of things to achieve that. You can carry out validation, which is basically to assess the quality or the appropriateness of the chosen sampling method. Okay, you can do that, and then of course implement proper quality assurance measures to minimize errors. Check conduct randomization checks. These are very important. Verify the data, cross-check it manually, and see that the data is actually being entered in the right way. Continuously monitor this information. Promptly address any issues that emerge, so that you don't have issues. And then it's very important that you clearly document the sampling methods and procedures. This is very important in increasing credibility of your study, and also if someone wants to conduct the same study, they can actually follow the steps that you actually undertook. We say that you can use formulas to determine the sample size, but you can also use statistical sampling software and tools. They can be R, you can use SPSS, you can use statistical analysis system. There are actually a variety of software that you can use for this purpose. Okay, so we have come to the end of this presentation. I want to thank you for listening.